If your RAG system hallucinates, it's usually retrieval. We'll build a filter-first retriever in Elasticsearch and add rerank so citations actually match the answer. You notice wrong facts or off-topic snippets in answers. That usually means the retriever pulled the wrong documents. By the end of this video, you will understand how to seed a small index, run BM25 retrieval, add new documents, apply metadata filters, and re-rank the candidates so the final answer cites the right text. This will help reduce hallucination and make citations trustworthy for downstream generation. I'm Professor Pi, teaching search and IR from basics to advanced, with simple, concepts-first Python that helps you solve bigger, real-world problems. Context and motivation. Retrieval augmented generation works only as well as the documents you fetch. People reach for Elasticsearch when they need fast, scalable text retrieval with familiar controls for text scoring and metadata filtering. The pain point is candidate set quality. If your retriever returns noisy or off-domain documents, the generator will confidently invent answers. Success here means the top retrieved passages are relevant and come from the right source, fast enough for an interactive workflow. Concept overview. The idea is simple. First, narrow the candidate pool with metadata, so you only search within the trusted source. Then use a strong first-pass retriever like BM25 to find likely hits. Finally, rescore a small set of top candidates with a more precise signal to decide the final ordering. This combination cuts hallucination by keeping the model honest and by making the cited text actually present in the highest ranked result. Project preview. We will build this step by step. We will create an index and add one document, then run a BM25 query to see the top hit. Next, we add a second API document and compare what changes. After that, we apply a metadata filter to limit sources. Finally, we run a rescore step to re-rank the filtered candidates for final relevance before feeding them to the generator. First, we will create a minimal index and seed a document. This snippet uses Elasticsearch indices.create an index to seed one document. This snippet shows creating an index with a mapping and then indexing a single document. The code first calls indexescreate to make the index and defines the fields we care about. For example, a text field for the document body and a keyword field for source metadata so we can filter later. After the index exists, the code calls index to insert one document with an identifier and the text and source fields. The snippet typically uses an immediate refresh or a refresh parameter so the document is searchable right away. Seeding one document makes it easy to observe retrieval behavior before we add more data. Now we will run a simple BM25 search to get a baseline. This example runs an Elasticsearch search with a BM25 match query to get the top hit. This example builds a search body that uses a match query on the text field, so BM25 computes a relevance score. Then it requests the top hit by setting a small size. The important lines are the query definition and the size parameter that returns the highest scoring document. BM25 is the classical bag-of-words scorer that mixes term frequency and inverse document frequency to rank matches. If you increase size, you get more candidates at the cost of more post-processing. This simple step shows which document BM25 prefers before we add filters or rescoring. Next, we insert an API doc and rerun the same query to compare changes. This code inserts an API doc, then Elasticsearch search compares the new top result. This code first indexes a new document that looks more like an API reference, setting the same fields so the index contains a second document. After indexing, it triggers a refresh, so the new document becomes visible. Then the same BM25 match query runs again. The snippet demonstrates how a freshly added document can overtake the previous top hit if its text matches the query better. This highlights the need to control the candidate set because raw BM25 will happily surf across all sources and return whatever text scores highest. Now we will add a metadata filter to keep results inside a trusted source. This snippet applies an Elasticsearch bool filter, term on source.keyword, to constrain hits. This snippet wraps the match query inside a bool query and puts a term clause in the filter array targeting the source keyword field. The filter narrows the search to documents whose source equals the specified value without changing scoring mechanics. The top lines build the bool structure, the filter term, and the nested match. Because filters are cached and do not influence score, this step is fast and reliable for excluding irrelevant collections. Changing the filter value reduces recall to that source, but greatly improves trustworthiness of citations. Finally, we will re-rank the filtered candidates to pick the best passage. This snippet uses Elasticsearch search with rescore to re-rank filtered results for relevance. This snippet uses Elasticsearch search with rescore to re-rank filtered results for relevance. This snippet first retrieves a small candidate window with the base BM25 query and then adds a rescore block that reorders those candidates using a second scoring query or a scripted function. The rescore window size controls how many top documents get reevaluated. The rescore section can apply a different similarity, a query that emphasizes phrase matches, or a custom scoring function to surface the most precise passage. Increasing the rescore window can improve final ranking, but increases CPU cost. So it is a trade-off between quality and latency. Mapping to a real project, take the same pattern and scale it up. Use the filter to lock to your documentation index. Use BM25 as the fast first pass across millions of documents. Then rescore the top 100 candidates with a vector similarity or a phrase-focused query before sending text to the generator. That pipeline keeps latency acceptable while raising citation fidelity. Recap. This pattern is a filter-first retriever with BM25, then rescore. Use it when you need trustworthy citations from a known source. One caveat: overly strict filters can hide useful evidence, so pick filters that match your trust boundary. Wrap punch. One practical next step is to tune BM25 parameters or the rescore window size to trade off speed and accuracy for your corpus. If short, practical IR helps, subscribe and watch the IR videos.